Finally, our last method for solving quadratic equations is by using the quadratic formula. So we're actually going to solve this problem using the same quadratic equation that we had with our completing the square method. So this way you can see how the quadratic formula works and that we do get an equivalent answer to what we had with completing the square. When using the quadratic formula, we can always use the quadratic formula as long as we have a quadratic equation, so in any form. So even when we went back to the square root property and we had that 9x squared plus 25 equals 0, we can still use the quadratic formula. When we had the square root property where we had a quantity in parentheses squared, we can still use the quadratic formula. We would just have to simplify that quantity squared first and actually multiply that out. So we can always use this. Usually is the go-to for people because we know that it always works, but factoring is the fastest method if we can factor. In this case, x squared minus 6x plus 4, we can't factor it, so we have to use quadratic formula. So for a quadratic equation in standard form, ax squared plus bx plus c equals 0, the solution to the quadratic equation can be given by the formula, and you are going to have to memorize this. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So it's going to come back enough in your math career that you really need to memorize that formula. So that's what we're going to use in order to solve this x squared minus 6x plus 4 equals 0. So we have x squared minus 6x plus 4 equals 0. So in order to use the quadratic formula, we need to identify what a, b, and c are. So a would be our coefficient of x squared, which in this case would just be 1. B would be our coefficient of x, which would just be negative 6. And then c would be our constant, which is just positive 4. So all we're doing is just straight plugging in. So I'm going to have here then negative b. So that means I'm doing the opposite of whatever b is. So I'm going to write this as the opposite of negative 6. So you can see that there is the negative from the negative in front, and then b was negative 6, plus or minus the square root of b squared, so negative 6 squared, minus 4 times a, which was 1, and then times c, which is 4, all over 2 times a, which is 1. So just straight plugging the values in, and now we're just simplifying this. So from here, the opposite of negative 6 would be positive 6, plus or minus the square root, negative 6 squared would be a positive 36, minus 4 times 1 times 4 would be a minus 16, all over 2 times 1 is 2. Continuing underneath the square root, we would have 36 minus 16, which is 20, all over 2. From here, we do want to simplify our radical. So off to the side, the square root of 20, largest perfect square factor is 4, so we'd have square root of 4, square root of 5. So we would just get 2 square root of 5. So that means here that I have 6 plus or minus square root of 20 now becomes 2 square root of 5 all over 2. And then finally, we just want to simplify this by dividing with our denominator. So we're going to see if our denominator goes into each term in the numerator. So we're going to divide 2 into 6 and then 2 into 2 square root of 5. So if you want, you can write it so that way you can see how it is simplified with the 2 underneath each piece. This is helpful especially when you can't simplify, so that way you can see the fraction that you're left with. But in this case we can simplify. We get our final answer of 6 divided by 2 would be 3. Plus or minus, here we're only looking at the number in front of our radical and then the denominator, so 2 goes into 2 one time, so these would just cancel out to be 3 plus or minus the square root of 5. And this is the answer that we got in the previous video, so it shows that our quadratic formula also worked for a problem where we needed to complete the square. Again, if we wanted to write this in set notation, in solution set notation, we would have 3 plus the square root of 5 and then 3 minus the square root of 5. And that's how you use the quadratic formula.